Hey guys, we're going to go over the independent practice, page 43. I assigned 1 through 7 odd, and I also asked you to do number 8. The answer for number 1 is straight out 8 pounds. Number 3 is $9. For number 5, you're going to have to watch the video. You're going to have to see the table that's set up because it's kind of an involved answer, and I didn't have enough space to put it in that little square, so or on the side here. And number 7, you'll have to see the video too, but I'll explain what it says so far. To multiply means you're going to get larger batches. To divide means you're going to use unit rate. And I'll explain what that means, okay? You need to see an example going on. And then for number 8 as well, you're going to have to watch the video because it's kind of an involved answer, okay? All right, so let's get started. Always read the directions first. It says here, complete each ratio table to solve each problem. All right, we're going to start with the ratio table. This is number 1. To make 5 apple pies, you need about 2 pounds of apples. How many pounds of apples do you need to make 20 apple pies? Right. This is still a ratio. Even though they're rates, it's still a ratio. And you always got to write down what you're comparing. Now, luckily, the book writes it for you, which is fine. But you should be able to do it without it. I mean, it looks like we're comparing apple pies, right, with pounds of apples. So okay, and we're giving a ratio of, if I believe I got this down, 5 to 2. All right, and we want to know, well, how many pounds can we make? Sorry, how many pounds of apples do we need if we're going to make 20 apple pies? Now, fair warning, I hesitated because I almost put the 20 in the wrong place. Okay, you got to be careful where you put these numbers. It changes the answer drastically. All right. Now, here's the deal. Here's the deal. I've been trying to tell you this since the beginning when we started this whole ratio deal. It's all about relationships. Okay? So just watch what I'm going to do. I'm going to do this real fast just because it's a small enough number and I can make this work and hopefully understand what I'm doing. All right. So the way this is going to work, this relationship, for every 5 apple pies that you want, you need 2 pounds of apples. It's a relationship. It is a relationship. Okay? They go together. Use a pencil, a pen actually. It is a relationship. This is the group that you're working with, 5 to 2. Okay? For every 5 apple pies that you want, you need 2 pounds of apples. Now the question's asking, all right, I want 20 apple pies. I want 20 apple pies. How many pounds of apples do I need? Now I'm going to show you visually what this looks like. All right, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I believe that's 20. 1, 2, 3, yep, 5 times 4 is 20. Okay, so this is where I want to go. I want to go from here to here. I don't just want 5 apple pies, I want 20. Okay, now here's the thing. Here's the deal. For every 5 apple pies, I need 2 pounds of apples. All right, so what's going to happen, I'm going to need 2. And you know what, might as well put in the dots now. I'm going to make a ratio this way up to a point. For every 5, I need 2 pounds of apples. For every 5, I need 2 pounds of apples, 2 pounds of apples, 2 pounds of apples. Now, visually, you just solved the problem. Now, I want you to realize something. 5 to 2, 5 to 2, 5 to 2, 5 to 2. 20 apple pies means I need 8 pounds of apples. Okay? Look what we just did. That's one group of 5 to 2. Another group of 5 to 2, another group of 5 to 2, another group of 5 to 2. Okay, now here's the thing. We went from one group, we scaled up to make 4 batches of this. All right? So in a very real way, this is what we did. All right? Now, I said this already. Mathematically, what you just did is this. We have groups of 5 apple pies. How many groups of 5 do we need to get to 20? and you just saw the proof. You need 4. You saw the answer and the proof. You need 4. Okay. And just like I said before, whatever you do to one part of the fraction, not that ratios are fraction, but they behave like fractions, okay? And 2 times 4, again, we're going to do the same thing here. All right. Now what about the rest? What about the rest? You need to complete it, right? Well, here you multiply by 4. Maybe try multiplying by something smaller. Maybe instead of, let's just do times 2. And then times 2. Okay. I want you to see something. Here's our 5 to 2. By multiplying by 2, I'm saying I want 2 groups of this. 2 groups of the ratio 5 to 2. And here's your proof. 10 to 2. Or 10 to 4, excuse me. Alright? So, let's not forget, the whole point of doing the ratio tables is to also make equivalent fractions. So these 3 ratios are equivalent. They show the same relationship of 5 to 2. 5 to 2. 10 to 4 is the same as 5 to 2 twice. 20 to 8 is the same as the relationship 5 to 2 4 times. Now, of course, we need to write an answer. The question was, how many pounds of apples do you need to make 20 apple pies? Now, use the question to write a complete sentence. Okay? So then you write your sentence. You need 8 pounds of apples. Again, I know I said before, if you just write a noun next to it, it's enough. But sometimes, just to be more clear and more detailed, 8 pounds of what? Of apples. Okay, I hope this made sense. That's number 1. Number 3. Before leaving to visit Mexico, Levant traded 270 American dollars and received 3,000 Mexican pesos. When he returned from Mexico, he had 100 pesos left. How much will he receive when he exchanges these pesos for dollars? All right. Again, without looking at the table, if you're just reading what you read in front of you, we're talking about dollars and pesos. Dollars and pesos. Now, I know the table's a little different. I'm going to simplify it. Dollars to pesos. All right. Here's the deal. The relationship is, for every $270, this person got 3,000 pesos. Now, fair warning, I'm not going to draw dots. That's way too many. Okay, just not going to happen. All right, you'd see me cry first, and I don't think you guys want to see me cry at this point. So, I'm just drawing the table that's in the book. So, but the idea is the same. There's a relationship, just like with the previous problem. There's a connection. Okay? We're scaling down. We're scaling down. Okay? Now, if you know your math, you can probably just go directly to basically this. We have 3,000. I have 100. How many groups of 100 make up 3,000? In other words, 3,000 divided by how many groups do you need to make? And that's not really a good sentence, but you get the idea. You're breaking this up into groups so that you have groups of 100. How many groups is that? You could scale down directly. You could. But we're not going to do that. Okay? So, what's going on? I'm tempted to say the answer, but no, let's not go there. If you can't go directly, you know what? Let's just simplify. You have space here to finish out the ratio table. Use it. Now, I know in the other problem, I kind of went directly because it was easy. All right? And this for me is easy, but maybe not for you. Not because I'm smarter. I just have more experience doing this. So what I will let you see, not let you, it's not like I have a choice. You have your eyes. Use them. What do you notice about both of these numbers? They both end in 0. That means 10 can be a factor. I can make 10 groups out of 270, 10 groups out of 3,000. So we're going to scale down. Again, whatever you do to one, you do to the other. You're going to scale down. Scale down, scale down, scale down. Kind of messed up my division symbol there, but that's okay. And I'll just erase this one. You know what? Again, I think I already told you, if you watch my videos long enough, you know I have a little bit of OCD. I want it to be as perfect as I can. Now, believe me, it used to be worse. I would have actually torn this paper up and started over. No, I have to let some things go. Okay. How many groups of 10, or how many, if you have 10 groups, how much is in each group if you have 270? All right. It's 27. And this is going to be 300. Okay, now, if you don't believe me, by all means, please do the division. But trust me, I am not lying to you. Okay? If you're still not sure how to do long division, it scares you to pieces, I understand. Now, maybe just for old time's sake, I will do one more just to see that it's not that hard, to show you that it's not that hard. You can do this. All right, you're making groups of 10. You've seen me do this before. Can you make groups of 10 out of 2? No. What about 27? Yes. Again, 1 digit per column, or per place value, excuse me. I can make 2 groups of 10. That gives me 20. 27 minus 20 is 7. I don't have enough to make another group. I bring down the 0. How many groups of 10 can I make from 70? Look, basically what I did, I broke it down to this. And then I did this. Right? Yes. I changed the big monster into something I can handle. Okay? Now this. Ooh. Same idea. Can I make groups of 300 from 3? No. 30? No. 300? Yes. How many? Pues claro. Just 1, right? That makes sense? All right. Okay, now, do you notice I did something kind of weird? I just caught my mistake. Here's the 3,000. The dividend is right, but the divisor is 10. Although this will give me 10 as well, there is a connection. I want to show you how to do the division the correct way. So let me erase that. I'm glad I caught that before I went any further. Okay, now it should make more sense. Can I make groups of 10 out of 3? No. 30? Yes. 10 times 3 is 30. All right. You have nothing left. You have nothing but zeros. How many groups of 10 can you make from 0? 0. Okay, that gives you 0. Bring down that 0. How many groups of 10 can I make from 0? 0. Awesome. Okay, so now you saw the proof. All right. Now from here, we're still scaling down. Okay? To go from 300 to 100. Again, ask yourself, if you're making groups of 100, how many groups of 100 can you make? What are you breaking this up into? How many groups are you breaking this up into to get 100? You're going to make 3 groups, right? 100 plus 100 plus 100. And again, whatever you do to the top, you do to the bottom. How many groups? If you have 3 groups and you break up 27 into 3 groups, gives you groups of 9. Okay? All right. Now again, I'm not going to draw dots. Please, I hope you understand the math as you can visualize. It just gets smaller. I'm scaling down. I'm dividing. I'm scaling down. I'm dividing because I want a smaller batch. Yes. I want less. Okay. Now, can I break this down any further? No. These two don't have any common factors that I can think of off the top of my head. So, again, what sentence are you going to write? He will receive $9 I could add in exchange for 100 pesos if you want to add that. You know what? How long? It doesn't take that much work. In exchange for 100 pesos. All right, before I let this one go, I want you to notice something. The simplest form is this. For every $9, if you can imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, you get 100 pesos. That's the basic. I just noticed I wrote pesan. What is a pesan? Telling you guys, my head sometimes just goes out the window. If you caught that, good eyes on you, because I just caught it right now. Anyways, think about it. For every 9, you get 100. So if we have 3,000, you have to multiply this by 30 groups. 30 groups of 100. 100 plus 100 plus 100 plus 100 plus 100. 30 times. How do I know it's 30? Because 10 times 3 is 30. If I scale up, that means I have to make 30 groups of 9. 9 plus 9 plus 9 plus 9 plus 9, and so forth and so on until you get 270. There's a relationship. They're connected. Okay? They're two separate problems, really, if you think about it. But they're connected. There is a connection. There is a relationship. All right, that is number 3. I hope that helped. Okay, number 5. This is the one that maybe some of you freaked out by. I hope you didn't. But if you did and you still kept going, good for you. Don't be afraid of the math. Okay? Math is patterns. Math is being creativity. Music, if you're into music, it's nothing but creativity, which is math too. All right, number 5. Number 5. A punch recipe that serves 24 people calls for 4 liters of lemon lime soda, 2 pints of sherbet, and 6 cups of ice. All right, there's 3 parts to this problem. All right, bear with me. Part A is complete a ratio table to present the situation. Okay, fair enough. We're going to make a table. Now, in the book it says people served. I'm just going to put down people. Liters of soda. I'm going to make it a little bigger so I don't scrunch it. Liters of soda. Pints of sherbet or I think that's how you pronounce it. It doesn't look like that's how you spell it, but that's how you spell it. I'm just not sure about the pronunciation. And cups of ice. Now here's the situation. This is still a ratio. Now, so far you've seen nothing but ratios with only 2 things. This to this. But now, the reality is with ratios, you can compare as many things as you want. There's a relationship. There's a connection. All right? So, this is part A. Here's my table, and I'm going to fill in the numbers now. According to the problem, if I want to serve 24 people punch, I need 4 liters of the soda, lemon lime soda, 2 pints of this sherbet, and 6 cups of ice. That's my connection. And I'm not going to draw the dots. Please don't ask me to draw the dots. Okay? These would be fine, but then to draw 24 as many times as I need? Oh, okay, you convinced me. Look. 24 people, 4 sodas, sherbet, ice. Some of you are going to hate me for doing this. But let's do it, man. Let's just do this. Let's do the dots. The dots of doom. It's not really anything doomy about this. It's just a lot of work. But I need you to see how this works. I want you to see the connection. I want you to see what's going on. Okay? We haven't used green in a while. I don't think we've ever used green. Let's go green. Yay. All right. Okay. Here we go. 1, 2, 3, 4, 5, 6. That was easy. I love that one. 2. 1, 2. And then purple. 1, 2, 3, 4. And then finally pink. This is the one that's going to hurt. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, dear Lord. Okay. There's a connection, okay? This goes together. Now, part B asks you a very simple question. It may not be a simple answer, but it's a simple question. All right. this recipe is for 24 people. Part B asks, well, okay, we need to make it for 12 people instead. How's that going to work? If I want it for 12 people. 12 people. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I hope this works out. So instead of 24 people, I want 12 people. Here's my question for you. You're going to have to think about this. I have groups of 24. Now I have a group of 12. I'm scaling down. And if you're scaling down, you're going to have to divide. So my question for you is, how many groups of 12 can I make out of 24? Or, right? You should be able to see, look, I'm going to do this very lightly. I don't want to mess up my drawing. I have 2 groups of 12. So if I went from 2 to 1, that means I divided 24 into 2 groups of 12. No, I didn't, which you can see here, 2 groups of 12. So the simplest group would be 1 group of 12, right? Okay. You're going to do the same thing with this. 4 broken up into 2 groups. 2 broken up into 2 groups. 6 broken up into 2 groups. So 4 broken up into 2 groups. And I'll do it very lightly with the pencil so you can see. All right. 1 group, 2 groups. That gives me 2. 2 per group. Oh, I almost used the wrong color. 1, 2. Four divided by 2 is 2. So many colors. I'm dividing here 2. That means I'm making 2 groups of 1. All right. And this I'm breaking up into 2 groups. Guess what? You can kind of see it automatically. Oh, groups of 3. Yeah. Yes, 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 sir. 1, 2, 3. And yes, that was my marker that fell down. My highlighter, I should say. Okay. Whew. But again, there's a connection. For every 12 people, I need 2 cups or 2 liters of soda, 1 pint of sherbet, and 3 cups of ice. If I double it, I make 2 groups of this. There's my 6. 3 and 3. If I double this, that gives me 2. 1 and 1. If I have 2, 2 and 2, there's my 4. I have my 12. 12 and 12, 24. You can see how it works scaling up. Scaling down, you want less. Okay, we're still not done with with part B. Because now it says, okay, what if we need to serve 3 people? 3 people. Sorry, not 3, 36 people. All right. Now, just to help me out here, I'm going to rewrite what I wrote over there. I have 12, 2, 1, 3. 12, 2, 1, 3. Okay, there we go. 12, 2, 1, 3. Now, here's the deal. I'm not going to draw the dots for this one because I think you kind of get the idea, I hope. Instead of 12 people, we want 36. Again, this time we are scaling up. We are scaling up. So what's going to happen is we're going to multiply. Right? Now, if we have groups of 12, 12 plus 12 plus 12, how many groups of 12 do we need to get to 36? I kind of already said it. Now, if you know your times tables, you know you're scaling up by a factor of 3. Oh, all right. That's fair. So I'm going to have to do the same thing for all of them. Increase all of them and scale up by a factor of 3 for all of them. 6, 3, 9. Let's see. This would be the purple one. This would be the yellow one. The green one. And I forgot the pink one, the most important of all the people. All right. Feel free to draw the dots if you want, but it's easier to see scaling up than it is scaling down. Okay. Now, of course, there's one more part. We need to scale this down for 18 people. 18 people. Oof. Don't freak out. Don't freak out. Again, this is part B. Let me label it. This would be part B. This is part B as well. But now we're up to part C. Okay. You can't see what I just did, but there it is. Part B, part C. Now it says, hey, what if we need 18 people instead? What if our party is just 18 people? Don't panic. Do not panic. We have 36. We want groups of 18. We are scaling down. We're dividing this up into groups. How many groups of 18 are we talking about? Don't know. Well, I do know. There's two ways to do this. Okay? You can divide 36 by 18 and see what you get. Right? Or if you want to see it like this, excuse me. Or you can keep adding this till you get to that. You can do repeated addition, which is kind of what multiplication is, right? If I have 18 and 18, that's 8 plus 8, 16. 1 plus 1 plus 1, 3. Oh, my goodness. I have enough for two groups. So that means I can break this up into two groups. I break this up into two groups. Now, some of you might be a little comfortable with what you're going to see next, but I'll make it work for you. 6 broken up into two groups is 3. 3 broken up into two groups is... Uh-oh. It doesn't work, does it? Not evenly anyways. You're not going to have a whole number. You're going to have a whole number and a decimal. Or a fraction, but decimal would probably be easy. Alright. Now think of money. $3 divided by 2 people, you're going to get $1.50. Now, just trust me, that is the answer. I will set it up for you and you can finish it to prove it to yourself that it is the answer. Here we go. Let me highlight. If you are doing this, if you did it and you did everything I did, great. If you did something different and it worked for you, that's great too. But what I will ask you to do this again without looking at my answers. For those people that didn't get it, do what I just said. Because I was thinking, wait, that doesn't make any sense. If you got the right answer doing it your way, you don't have to worry about my way. Obviously, whatever works for you. If you didn't do it again. Don't just copy and say, oh, I get it. Do it on your own. Look at the math book again without looking at the answers. Can you really do it on your own? Oh, anyways, I promised you I would set this up. 3 divided by 2 is the same as this. The dividend is 3. The divisor is 2. Go ahead and what I asked you to do. You can, do the math yourself. 9 divided by 2 is 209. Okay. All right, that is number 5. Number 7. I'm going to have to show it to you. I know the answers are there, but if you don't understand what's going on, it's not going to make any sense. All right, number 7. Complete the graphic organizer to explain how equivalent ratios are used to find larger quantities and smaller quantities. Okay. All right. This is number 7. I hope this makes sense. So bear with me. I know this lecture is going on a little long, but I'm giving you a lot of detail. And I hope you appreciate this, because next year it may not be like that. Your teachers are going to trust you to do more thinking on your own. Okay? And I'm getting there too. Believe it or not, I'm actually letting you do more and more. So remember, equivalent ratios. This is an example of equivalent ratios. Right? These are equivalent ratios. All right. If I'm going from this and I want more, I'm going to use multiplication. To get more, you multiply. scale up. Okay? And an example, a real-world example, well, again, the book said a larger batch. So, 1 cookie, 2 muffins. You want more? You scale up. If I double the recipe, now I get 2 cookies and 4 muffins. I'm scaling up. I'm going to use the operation of multiplication. All right? Now, I'm going to use another page because I'm going to run out of space here. And again, this is all just to explain an idea that you should... I think some of you get it. You get it. You just need to have the words to go with what you... Apparently, I need words. You need the words to understand what you get. Okay? So here we go. 3/6, 2/4, 1/2. Same fractions, but in reverse. Okay. We are scaling down. We're scaling down. All right. Just going to check something. All right. Operation used for this, you already know. You know what? Let me look back at the notes. Did I use the multiplication symbol for that? I did not. Oh, yeah, I kind of did. All right. Anyways, the point is, for this, when you're scaling down, operation used, division. Okay? You scale down when you want less. Okay? If you want less, you scale down. Maybe again, the recipe that I used was 3 cookies and 6 cupcakes. I know I said muffins the other example. Cupcakes are tastier. Okay. But this is enough for 3 people perhaps. But it's just me. It's just me. I don't want to eat this much. So I want a smaller batch. I'm going to scale down. I'm going to divide. All right. So number 1, a real world example would be you're looking for the unit rate. How much for 1? Right? If I switch this around, it would be a unit rate. 2 cupcakes per cookie. Right? But in other words, you want a less amount. You want a smaller amount. All right. That's number 7. Hope this helped. Scale down when you want less. Scale up when you want more. And to scale up, you multiply. To scale down, you divide. All right, number 8. Melody used the ratio table at the right to find the number of people served with 15 pounds of ground turkey. Find her error and correct it. All right. I'm going to copy the table. There it is. That's just a number. It's not the table yet. Pounds of gobble of turkey. People served. Peoples. Yeah, you're not really supposed to say peoples. People served. All right. We have this 2 to 6. And then 1 to 5. And the question is, if we have 15 pounds of turkey, how many people do we have? Now, they wrote 19. What happened here? Look. To go from 2 to 1, it looks like this person just subtracted 1. It looks like she subtracted 1. Right? And here, they scaled up. Oh, so let me use the words. I'm sorry. She scaled down. She subtracted. Now, I know what you're thinking. Hold on to that thought. Here she added 14. Here she added 14. Now, after everything I just showed you, and I just explained it just now, when you're scaling up or scaling down, you're not subtracting or adding. You're multiplying and dividing. Okay? So, just for my own sake, I'm going to see if I can fix this. Maybe I can't. Maybe it'll be an impossible thing. Who knows? So here we go. Now I know the problem isn't asking for this, but I might ask you on the quiz. Hint, hint. All right, same idea. 2 pounds of turkey, 6 people served. So for every 2 pounds of turkey, I know I can feed 6 people. So with 15 pounds of turkey, how many people can I serve? Now, let me ask you something. It should make sense to you that if we're going to increase the amount of turkey, you should be able to feed more people, right? So the answer is going to be larger than 6. Okay, just keep that in mind. Just a little reasoning there. All right, 2 and 6. You know what? These numbers are small. Guess what I'm going to do? No, don't do the dots. Don't do them. You're killing us. Come on, these are numbers. These are small. I don't mind when it's small. There's a relationship. 2 to 6. 1, 2, 3, 4, 5, 6. 2 to 6. All right. There's no way I can make groups of 2 to get to 15. Just isn't going to happen. It's not going to happen. But I notice that they're both even numbers. I can divide both of them by 2. You should be able to see in the drawing too. I can break this up by 2. So 2 divided by 2 is 1. Or 2 broken up into 2 groups gives you groups of 1. Right? And then 6 broken up into 2 groups is 3. So now I have 1 group and 3 groups. Again, 2 groups of 1, 2 groups of 3. All right. The relationship. And if you notice, it's 2 to 6, right? Is 1 to 3 twice. Here's my 1 to 3. Here's my 1 to 3. Right? But now I want 15. Oof. Oof. I want 15. There's my 15 pounds of turkey. I went from 1 to 15. I scaled up. I scaled up. And if you scale up, you're going to use multiplication. So how many groups of 1 do I have here? How many groups of 1? 15. That's right, it's 15. All right. And then the same thing here. You multiply this by 15. And what's 3 groups of 15? Or 15 groups of 3? Oh, here we go. You know what? I started it. Might as well follow through. 15 groups of 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's... Wow. That's only 9 groups of 3. Oh my god. 10, 11. 1, 2, 3. 1, 2, 3. That is 12 groups of 3. Oh my god. Let me make sure I got this right. I hope I didn't mess this up. 15 groups of 3. 1, 2, 3, 4, 5, 6. Let me circle with a pencil in case I mess up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. Dear Lord, that means it's 45 people. 15 pounds of turkey can serve 45 people. And that's it for the IP. Thank you for staying awake this long. It's almost 40 minutes.